some point in the Carboniferous period, beginning some 359 million years ago. The amniots include animals now classified as the reptiles, including birds, and the mammals. The embryo of an amniot has extracellular membranes, including an amnion. So this is figure 29.15. Shows that the amniots consist of three lineage, which is diapsid school, anapsid school, and synapsid school. And first one, the turtles. This is turtles, which the school is anapsids. That is, it has no opening behind the orbit or isoket. And second is all the reptiles, snake, lizards, tortoises, crocodilians, and including birds also. And in which school is diapsid school, or has two opening behind the orbit, which is dorsal temporal opening and lateral temporal opening. And the last one is the mammals, have the synapsid school, which is the school has one opening behind the orbit, which is lateral temporal opening. That's it. This is the timeline of in the timeline of the evolution of the amniots. Diagram shows an overview of the presumed evolutionary relationship among amniots, including the major groups of reptiles. The amniots ancestor evolved in the Paleozoic era. Historically, the openings in the school were considered evidence that there were two major groups of the reptiles, with the turtles separate from the other reptile groups. This historical understanding of the turtle evolution is presented in this figure. A modern view, not shown, proposes that the turtle are Archosaurus along with crocodiles and birds. Systematists are continuing to explore the evolutionary relationship of the reptiles, which now include the birds. For example, the classical view of reptile evolution considers the turtles or anapsids as an independent lineage separate from that of the rest of the reptiles, which are diapsids. The modern view of turtle evolution places turtles within the Archosaurus with birds and crocodiles. This would mean that the anapsids are really just highly specialized diapsids. According to the classical view, all the other reptiles except the turtles are diapsids because they have a skull with two openings behind the eyes. The Tigodons are diapsids that gave rise to the Ichthyosaurus, which returned to the aquatic environment, and the Pterosaurus of the Jurassic period, which had a keel for the attachment of large flight muscles and air spaces in their bones to reduce weight. Their wings were membranous and supported by elongated bones of the forefinger. Quetzalcoatlus, the largest flying animals ever to live, had an estimated wingspan of nearly 3.5 meters, which is over 40 feet.
Hello there. So about the dinosaurs, there will be 4 things that I'll be talking about in this video. So the first thing is the bipedal stance in dinosaurs. The second thing is the evolution of wings. The third one is how did the dinosaurs die, and fourth is the proof that the dinosaurs had extinct. Here, I'm going to list out the types of bipedal movement. The first one is walking, second, running, and the third one is hopping. Bipedal stance in dinosaurs frees the forelimbs and allow them to be used for purpose other than walking, such as manipulating prey. So the second thing that I'll be talking about is the evolution of wings in dinosaurs. It was pre-adaptive for the evolution of wings in birds. Did you know that dinosaurs evolved their wings and feathers before they could even fly? In fact, their feathers are not used for flight, but instead they are used for insulation against cold weathers. So the third thing is, how did they die? Did you know that dinosaurs dominated the earth for about 170 million years ago before they died at the end of the Cretaceous period? It is believed that a massive meteorite had struck the earth, resulting in cataclysmic events that disrupted the ecosystems and destroyed many other living organisms on the earth. So after listening that the dinosaurs had extinct. How far do we know that it's true? So, this hypothesis is supported by the presence of a layer of iridium on the Earth's surface, which is something rare to be found on the Earth because it is usually found in meteorites. So, that is a proof that meteorites had struck the Earth, resulting in the extinction of dinosaurs. So, you guys have to stay tuned to listen to what my friend Nurul Hani has to say about the human medicine in the next part.
Some of the most powerful applications of genetic engineering can be found in the development of drugs and therapies for human disease. In fact, this technology has led to a new industry, animal farming, which uses genetically altered vertebrates such as mice, sheep, goats, cows, pigs, and chickens to produce medically useful pharmaceutical products. To accomplish this, the human gene for some useful product is inserted into the embryo of a vertebrate. The embryo is implanted into a foster mother which gives birth to the transgenic animals which contains genes from the two sources. An adult transgenic vertebrate produces large quantities of the farm product in its blood, eggs, or milk from which the product can be easily harvested and purified. An example of a farm product used in human medicine is human epitropine. This medication is important in the treatment of individuals who have a hereditary deficiency of this protein and so are at high risk for life-threatening blood clots. Approved by the FDA in 2009, the bioengineered drug known by the brand name Bitrine is purified from the milk of transgenic goats. There is an alarming shortage of human donors organs to fill the needs for hearts, kidneys, and livers. One solution is xenotransplantation, the xenotransplantation of non-human vertebrate tissues and organs into humans. The first such transplant occurred in 1984 when a team of surgeons implanted a backbone heart into an infant who unfortunately lived only 20 days. Although apes are more closely related to humans, pigs are considered to be the best source for xenotransplants. Pig organs are similar to human organs in size, anatomy, and physiology, and large number of pigs can be produced quickly. Most infectious microbes of pigs are unlikely to infect a human recipient. Currently, pig heart valves and skin are routinely used for treatment of humans. Miniature pigs whose heart is similar to miniature pigs whose heart size is similar to that of humans' immune system to minimize rejection.